This Week in Science and Education is presented in association with the Science Coordinators and Consultants Association of Ontario. Visit their website at sccao.ca.
This Week in Science and Education is brought to you in part by the University of Western Ontario, www.uwo.ca. We thank them for their support. This Week in Science and Education is also brought to you by Laurentian University. Check out Laurentian at laurentian.ca. We thank them for their support.
Hey everybody, it's time for This Week in Science and Education. This is T-WiSE, episode 72, recorded Thursday, March 8th, 2012. Mission to Moon without leaving the Earth. Hey everybody, thanks for taking the time to join us today. We appreciate that. We have a special guest with us today. On my right is Dr. Gordon Osinski from the University of Western Ontario. And we're going to find out how just do we get to the moon without leaving the Earth. We'll find that out really quickly. But before we do, let's welcome our co-host, Colin is normal from Kawartha Pine Ridge District School Board. Hey, Colin.
Colin is normal. I'll take it. How you doing, Kev?
You are far from normal, and that's why we love you, man. I'm doing well. And we have a fill-in today for Dr. Thomas Merritt. We've got James, James from the past, who's been with us before. Hey, James, how you doing up there at Laurentian University?
Doing well. Hope you guys are doing well too.
We are fantastic. Thanks for pinch hitting today for Thomas. I understand he's on the golf course, or he's, I don't know, surfing or something. What's he doing?
He's surfing in beautiful downtown Chicago, Illinois. I don't think he's doing a whole lot of surfing.
Well, you know what? I love Chicago, though. It's an awesome city, so he's probably having a really good time. I bet he's really disappointed he's not with him.
He's having a great. He's at a conference full of other fruit fly biologists, so it's a relative consideration, I guess.
Well, we all wish we were there for that, eh?
Who doesn't?
All right, guys. Let's get to our guest. Dr. Oz is with us. Not the Dr. Oz from Oprah, but nevertheless, a genius in his own right, I'm sure. Thanks very much for taking the time to be with us today. Appreciate it.
You're welcome.
So let's get it rolling. Tell us a little bit about who you are and your research and how we get to the moon without leaving our seats.
Sure. So, my name is Gordon Osinski. I've been a professor here at Western for about 4 years now. And I'm actually the Industrial Research Chair in Planetary Geology, sponsored by the Canadian Space Agency and MDA Space Missions, the manufacturer of the Canadarm. And so, because of that, a lot of my research is really driven by planetary exploration, figuring out the processes and the history of the Earth, Moon, and Mars, and increasingly about how we're going to get there and preparing for future space missions. And that's kind of driven this mission to the moon without leaving the Earth endeavor.
So let's learn a little bit about the mission then. Tell us a bit about the project.
Yeah, so actually this was all funded by the Canadian Space Agency over the last 2 years. And this was a series of contracts that they gave out to various organizations, and they call them analog missions. And so we're essentially simulating some aspect, or in our case, a end-to-end mission to the moon. And the goal is really there's several goals. One is to do some science, to learn about processes that are occurring on the moon and on the Earth. In our case, we went to a meteorite impact crater up in Labrador, and actually closer to home up to Sudbury, where one of our co-guests is hosted, where of course it's the site of a large meteorite impact structure.
That's actually where James is broadcasting from right now.
Yeah. So Sudbury's kind of in the middle of a 250 kilometer diameter impact crater that formed a couple of billion years ago. And so one of our goals is to do some science, to learn about the surface of the moon by studying these analog landforms on Earth. The other big reason why the Space Agency is interested, though, is to learn how to get to the moon and how to run these missions. One of the things in Canada is that we haven't had too much experience participating in planetary missions. And so the cheap way to do that is to simulate a mission on Earth before we get involved in these drastically more expensive missions. Sure. And so when we did both the Sudbury and the mission up to Labrador, we had a team up in Labrador and in Sudbury, and we had a mission control set up here at Western. We were simulating those operations and sometimes the communication delays. And it's if all you have is basically looking through a computer monitor, data being sent back from a location, it's an incredibly different thing than being there yourself, especially as a geologist, where you're just used to wandering around in the field, picking up rocks, and being able to have the whole context of the scene around you. And so it was a big challenge for the mission control team to come up with hypotheses based on, again, snapshots of data. And that's kind of one of the biggest things we were looking at, is the operations. How do you go about the operational side of things there?
I'm going to ask the most obvious question. Sorry, guys, I'm going to jump in ahead of you here, but haven't we already learned how to get to the moon? Didn't we do that like 40, 50 years ago? What's different now than back then?
Yeah, no, I mean, that's a really good question. We have, of course, been to the moon, but it was before I was born, early 70s, I guess.
Yeah.
So there's two things. One, the technologies have drastically changed. And two, the people who were involved in Apollo, most of them are no longer involved in the kind of the space world. And so we've lost a lot of that knowledge. Regardless of that, the technologies have, and it's almost every week that there's new developments in computers and all forms of technology. I mean, you can imagine how things have changed in almost 40 years now.
We're probably not going to get there on 16 amps or less now, right?
No,
Yeah.
no. And a big thing we were looking at is the use of robots. So, I mean, the Apollo astronauts were very crudely equipped. They basically had a rock hammer, scoops, shovels. They had a primitive camera, and that was really about it. And so today, in geology on Earth, we can be equipped with various handheld spectrometers that really do look like Star Trek phasers, where you can go up to a rock and get a chemical analysis on the spot. And then we can have robots kind of either following behind us, going out ahead of us, and helping the astronaut do geology. And so no one's done that yet. And so we've got to relearn about how robots and humans can work together. And there's times when robots hinder a human, and there's times when they greatly help humans.
Right. I think it's going to be my mission, guys, to have the first iPad on the moon. I'm going to see if I can't
Nice.
get it there. No.
I bet it's actually not that far away.
Sorry, James?
I said, I bet you it's not that far away.
No, yeah.
Might have been part of the specs on the iPad 3. I noticed that just came out. But anyways, I could digress on that all day. James, let's go to you, actually, for the first question or comment for Dr. Osinski today.
Well, I'm interested because I'm a bit of an amateur kind of space nut myself, but I'm interested from the perspective of, I guess, the mandate of what you guys are trying to do with VROC and help connect researchers to high schools and stuff like that. I'm a molecular scientist as opposed to a planetary scientist, so we're talking about two opposite extremes, but one of the similarities that exists here is I spend my time looking at chemicals, things that you can't put your hands on, in the same way that Gordon would be spending his time analyzing things that people can't put their hands on either. In terms of what you think, and maybe you haven't thought about this, but what you think research like this could bring to, I guess, engaging high school students or younger, even entry-level undergraduates into pursuing further careers in terms of research. Can you think of anything that might help sort of kickstart that process?
Yeah, no, that's a fantastic question. And actually, on one of the slides in the presentation, I put together this kind of the main reasons for doing this, so this terrestrial analog research. Why do we go to these places on Earth that are analogs for other worlds? And I've touched on a couple, which are really to learn about the science and to test and to train future astronauts or the managers that would go there and to kind of test the technologies. But I do see one of the key things as engaging the general public and students. It's one of the amazing things about planetary science and space missions, but it's one of the drawbacks is just how long it takes to get there. And so, I mean, some of these missions take multiple years, even decades to come to fruition. And how do we keep people interested? How do we keep the public, let alone grad students and undergraduate students, through that duration? And so I see these analog sites, many of which are up in the... Canada is blessed with an amazing geography. I've spent 12 summers working up in Nunavut at some fantastic places that really do approximate, well, as close as we can get to on Earth, Mars and the Moon. And so these are great places where, because we can't go to Mars and back to the Moon yet and pick up a rock ourselves, well, we can go to places like this, simulate these missions and kind of really hopefully bring to the public and students a little bit more reality as to how we're going to do this, the technologies that we use, etc. And what we've tried to do in when we went to Sudbury, we actually teamed up with Science North there, the big science center, and we did a series of activities with them and public talks. In Labrador, we teamed up with some of the local communities, the Innu communities there. One of the interesting things about the impact crater in Labrador actually is that the closest community is Natwashish, I guess it used to be Davis Inlet, where we hear about a lot in the news for a lot of negative reasons. And it turns out this impact crater has it's a focus for caribou migration, and there's a big lake there where they do a lot of fishing, and they have a healing lodge on that lake. And so when our team was in the field, they were interacting a lot, at times almost daily, with the kind of Innu kids and the local community there. And I mean, they find it fascinating too, to kind of, it's fascinating putting that their traditions and their history with some of the talking about, well, an asteroid hit here 30 million years ago, and seeing their reactions to that too.
When I was talking with Thomas when I was on the show before, one of the things that we discussed was the idea that doing basic research is the stuff that ends up in the high school textbooks. And it's interesting, especially from the perspective of what Gord is talking about. Kids start learning about the moon and planets at a pretty early age, and it's presented to the general public in a very encyclopedic form. I think one of the nice parts about what he has the opportunity to do, especially on Earth, you can draw students in, even younger students, and have them get a chance to see how complicated this stuff actually is to make it actually go from before it gets into the textbook. That's the thing that still sticks out in my brain when I think about teaching even young undergrads, but older than high school students, is trying to make them appreciate how complex the actual doing of the actual science actually is. And this seems like a neat project because you can get around, you can sort of engage with people hands-on in a way that they wouldn't be able to do. I always laugh at my own students because I'm still constantly amazed at the Mars rover projects. And literally, it's like somebody taking a rubber band and shooting a spitball at something a bazillion miles away and hitting it. And but a lot of students just seem completely oblivious to that. So this is a kind of a neat way to bring them back in, bring them into reality. So it's very neat work.
Hitting it and landing it safely, I might add.
And landing it safely. And having pictures, without breaking the camera and having all the pictures come back.
Yeah, absolutely.
Yeah, I mean, I think, I have a 4-year-old son now, and I mean, it wasn't me, but he's into planetary science and the planets and things, and he has his placemat on his table at dinner, and he's going off and naming the planets. And one of the things we were talking a little earlier is we can use planetary science and exploration, or just planetary exploration, as an exciting theme to get, I think, kids interested in science and engineering kind of anyway. It's often, I mean, you can teach virtually anything you want to with this kind of framework of, let's say, let's talk about what are the technologies we need to get to Mars or the Moon, and what's the science that we're going to do when we get there. And you can teach physics, chemistry, math, geology, biology, and hopefully get them interested at a young age. And we're doing a lot of work actually here in London and taking some of this work from the analog mission into the classrooms, and the kids absolutely love it.
Yeah, it's a way to connect the fundamentals with the actual, something a little bit more thematic. So something that they can relate to, looking up in the sky, seeing the stars, planets, with the actual hands-on, doing basic chemical measurements and things like that. It's the same thing with us, right? It's forensic science. It's the same sort of thing.
Yeah.
I'd like to get Colin's comments on this, but before we do, I'm going to take a quick 2-minute break to thank our sponsors. We'll be right back with Dr. Osinski from Western University. Thanks, everybody, for sticking with us.
This Week in Science and Education is brought to you by Sheridan Institute of Technology and Advanced Learning. At Sheridan, students shine brighter. Check out sheridanc.on.ca.
Hey everybody, we're back with This Week in Science and Education. Thanks to our special guest today. It's been a great discussion with Dr. Osinski here from Western University. Colin, before we broke, I wanted to give you a chance to jump in, and then I didn't let you, so let's do that now. Quick comment or question, please.
Well, I'm sitting here just enjoying the conversation because this stuff is right in kind of the wheelhouse of the stuff I love, the intersection of astronomy and the fact that you're going to northern places to do some of this research, and I've followed some of these analog mission stuff, some of the things to Houghton Crater and things like that in the far Arctic in the years past. Yeah, and it's wonderful stuff. You mentioned something that I found was really fascinating. I'm sitting here thinking about it. Because we talked about 40 years ago, we sent people to the moon and they had like hammers. And now we spend a lot of money on rovers and on satellites and machines that we send into space. And you're talking about how do both of those things work together. There's some benefits to what humans can do and there's some benefits to what robots can do. I'm really interested in what can we do together that we couldn't do separately.
That's actually something I'm not sure I have the answer for, but was actually one of the main driving forces for our analog mission. There's actually there's kind of a couple of extreme end members actually. A lot of folks down at NASA in the US are actually very against taking robots with us when we take humans, because current robot technology is not. Well, the biggest thing is actually the speed and the mobility of these current rover platforms. One of the most valuable things that an astronaut is going to have when they go back to the moon, or if it's an asteroid on Mars, is time. And so every second that is wasted with him or her looking behind, waiting for the robot to catch up, is an important thing. So that's maybe a technology thing. Maybe we'll get there. But then there's a case of, how exactly will you use or not that robot that is with you? Is it just going to be kind of a glorified tool carrier? Is this something that you reach down, pick up your tools, and you put your samples on, and it stays with you? That to me seems a bit of a waste of the ingenuity of engineers and all the development that's gone into these platforms. So what actually we looked at with our analog mission was to have you send up a rover ahead of time. So you would do what we call a precursor mission, where you'd have a rover up on the moon for about a few months. Obviously we weren't able to do that for that length of time, but we had the rover going around collecting data that we then used to plan out more exactly what and where the astronaut would go to and what he or she would collect. It's really about maximizing that time. And then you can also do the follow-on work. You could do some work there on the surface and leave the rover behind to do follow-up work, which again is something that the Apollo astronauts couldn't do. And actually that's a really valuable thing, because it happens to me and happens to all geologists time and again. Especially working in the far north, where it's similar. You get a limited length of time, like 3-4 weeks in the field that summer. You can only bring back a limited mass of samples, and it's another 12 months before you can go back there. And you get back, you analyze the first rock, and it's like, oh, I should have collected this sample or analyzed that. And with having a robot there afterwards, you could still probably do that. Again, one of the trickier things is with current technologies is how they work there both together. And we did find several uses. For example, and it again comes down to maximizing time. There are certain things like carrying out geophysical surveys of the subsurface, where it's not really in the astronaut's interest to, let's say, walk up and down along these lines for half a day collecting data. That's something that's really that's something the rover is good at and plan. You can just basically plan out a path, hit go, and leave the rover to do its job, and then the astronaut can go off and again take in this context and do some more thinking on the spot. But it really is early days. It's an amazing thing that even NASA has not done really many or any of these really fully simulated, integrated analog missions. So there's a lot more work to be done in this area.
if you are a student out there, one of the exercises you can take away from this is how many impact craters do you think there are on Earth? In fact, let's quiz Colin. Colin's an amateur space enthusiast. I'm going to pull up a slide right now that shows them. Colin can't actually see this, so let's see if Colin has an idea. Colin, how many impact craters are there?
What size, Kevin?
Dr. Oz, I'm going to turn that one
I'm just
over to
throwing
you.
questions back at him because I'm not going to come up with a pretend answer here. I'm just going to pretend that I know. Roughly, what size and above, Kevin? We're talking 10 kilometers and above or 100 kilometers and above?
200 meters and above.
A few hundred meters and above that we know of? There's
Thanks for bailing me out on that one.
Okay.
Wow, man, I can think of... It's got to be in the hundreds, I would think, at least. I don't know the number, but I mean, we know of a lot of impact craters, especially in areas like the north where we can still sort of see them. And a lot of them get wiped, I know, as we've got tectonic activity, so we don't have, a record that lasts very long. But I know there's some. They're always finding ones like in the desert, in Africa and places like that through some of these satellite surveys. So I'm going to guess at least we know about in the hundreds.
So let's not actually tell him the answer. Let's just say if he's close or if he's way off.
It's it's hundreds, but not more than 2.
All right.
So I'm within an order of magnitude. I'm okay.
Yeah.
That was one of the slides that Dr. Osinski brought along that I just showed as part of the presentation. Fascinating. So, Colin, not bad. Good job. But for you students out there,
that's awesome.
James, I want to go back to you for another quick question to Dr. Osinski, please.
What kind of, I think, I still want to come back a little bit to the idea of actually collecting the chemical measurements. What kind of, on the analog mission, are you actually going to be using the exact same types of instrumentation and things like that you would be using on the moon?
That's another great question. The focus of our analog mission was really more on, again, the operational side of things and the science and not technology development.
Right.
So, and our budget didn't allow us to use a $30 million science space instrument on one of the rovers. But having said that, we were very cautious and careful to use technologies that either have flown on previous missions or that are in development. So, again, in the last few years, there's been this explosion of so-called handheld instruments that you can take into the field. One that we used is X-ray fluorescence spectrometry, and you can again take this phaser-looking instrument, point it at a rock, and you can get a chemical analysis. And while XRF hasn't flown on a mission, there are 2 or 3 instruments that basically give you the same data. And so we were able to use this instrument that is off the shelf, you can buy a few tens of thousands of dollars, and use it as a proxy. Now, there are some other really interesting stories where, the best one is an instrument called CHEMIN, CHEMIN, which is the chemical mineralogy instrument that is flying on the Mars Science Laboratory that's currently on its way to Mars. So this was an instrument developed by NASA for this Mars rover mission, and it's actually now being turned into a commercial endeavor on Earth. And essentially, it's a red pelican case size instrument, in this case X-ray diffraction. So that gives you information on the minerals in the rock as opposed to the chemistry. And so we were able to use that instrument too, which is in a slightly different configuration on its way to Mars right now.
Gentlemen, I'm afraid that we've reached the end of the time allotted for this show. That's always one of our challenges. We have such a great discussion, but we don't have time to continue it, I'm afraid, at this point. But maybe you could leave us with a lasting thought. What is it about your job that you just love every day?
Oh, wow. I think the inspiration that my students give to me is one of the key things. They keep me going. And there was a great story, again, just during our last analog mission, right at the very end of it, one of my postdoctoral fellows, John Moores, actually got the notification that he was selected by NASA to participate in this Mars Science Laboratory mission.
Yeah.
So here was us saying that. Yeah, so here was us saying, well, this is great training for someone who would be participating in a mission, and then kind of right at the end he got the official notification. So that was just fantastic.
That's great stuff.
Yeah.
More information on you, on the project, where would you direct people to go?
So there's a couple of sites. I have my own personal research website, which is spacerocks.ca. And then I'm part of the Centre for Planetary Science and Exploration here at Western, and you can find a lot more information about the analog mission through that website, and that's just cpsx.uwo.ca.
Super. And we'll put all of those links up on the show notes. Show notes can be found at twise.vroc.ca. That's twise.vroc.ca. And Dr. Osinski, I really want to thank you for your time today.
Thank you. It was a
so
pleasure.
much for coming on the show.
Yep.
It's been a pleasure.
Thanks a lot.
Dr. Osinski has joined us from the University of Western Ontario today. He's been our special guest, and would like to thank James and Colin, of course, for helping me out today. Thanks, gentlemen. It's been fun. And thanks, everybody at home and at schools for logging in and checking us out. We really appreciate it. See you next time on This Week in Science and Education. Take care, everybody.